Recap. Viral zoonosis. Definition: zoonosis are diseases of vertebrate animals that can be transmitted to man either directly or indirectly through an insect vector. When an insect vector is involved, the disease is also known as an arbovirus. Arboviral disease. However, not all arbovirus diseases are zoonosis. However, the transmission cycle takes place exclusively between insect vector and the human. Dengue and urban yellow fever. Examples of viral zoonosis that can be transmitted to man directly include rabies, hantavirus, Lassa, and Ebola fever. Rabies virus, member of the Lassa virus of Ritoviridae, single-stranded RNA enveloped virus characterized by bullet-shaped appearance with 6 to 7 nanometer spike projection, volume 130 to 240 nanometer, negative sense stranded RNA coded for 5 protein GMNLS, exceeding wide range of hosts. There are 5 other members of the Lassa virus: Mucola and Leucoplast and Divinac, EBL1, EBL2. Divinac and EBL2 have been associated with human rabies. Rabies virus, bullet-shaped under the direction microscope, matrix protein, glycoprotein, envelope membrane. Epidemiology: rabies is a zoonosis which is prevalent in wildlife. The main animals involved differ from continent to a continent. In Europe, fox and bats. Middle East, wolf and dog. Asia is dog. Africa, dog and mongoose and antelope. North America, foxes, skunk and raccoons. And South America, dog, vampire bats. Pathogenesis: the commonest mode of transmission in man is by the bite of a rabid animal, usually dog. The rabies is an acute infection of CNS which is almost invariably fatal. Following incubation, the virus replicates in the striated or connective tissue at the site of incubation and enters the peripheral nerve through the neuromuscular junction. It then spread to CNS in the neuron of the Schwann cells. Terminally, there is a widespread of CNS involvement, but few neurons infected with the virus show structural abnormalities. The nature of the profound disorder is still not understood. Lab diagnosis: histopathology, negri bodies are pathognomonic of rabies. However, negri bodies are only present in 71% of the cases. Rapid virus antigen detection: in recent years, virus antigen detection by IF immunofluorescent has become widely used. Corneal impression or neck skin biopsy are taken. The direct fluorescent antibody technique thus is commonly used. Virus cultivation: the most definitive means of diagnosis is by the virus cultivation from saliva and infected tissue. Cell culture may be used, or more commonly, the specimen is inoculated intracerebrally into infant mice. Because of the difficulties involved, this is rarely offered by diagnostic laboratories. Serology: circulating antibodies appear slowly in the course of the infection, but they are usually present by the time of onset of the clinical diagnosis of the rabies. This is the negri bodies in the neural cells. Process of the test. Management of and prevention: pre-exposure prophylaxis. Inactivated rabies vaccine may be administered to persons at increased risk of being exposed to rabies. Examples of veterinarians, animal handler, laboratory worker. Post-exposure prophylaxis: in cases of animal bites, dogs, cats in rabies endemic area should be held for 10 days for observation. If signs develop, they should be killed and their tissue. Wild animals are not observed, but if captured, the animal should be killed and examined. The essential component of the post-exposure prophylaxis are the local treatment of the wound and active and passive immunization. Once rabies is established, there is nothing much that could be done except intensive supportive care. To date, only 2 persons with proven rabies have survived. have survived. Post-exposure prophylaxis on treatment surgical debridement should be carried out experimentally. The incidence of the rabies in animal can be reduced by local treatment alone. Passive immunization, human rabies immunoglobulin around the area of the wound to be supplemented with an IM dose to confer short-term protection. Active immunization, the human diploid cell vaccine is the best preparation available. Vaccine is usually administered into the deltoid region and 5 doses are usually given. There is convincing evidence that combined treatment with rabies immunoglobulin and active immunization is much more effective than active immunization alone. Equine rabies immunoglobulin is available in many countries and is considerably cheaper than HRIG. Rabies vaccine. The vaccine which are available for human or present are inactivated whole virus vaccine, nervous tissue preparation, simple vaccine associated with the rare complication of demyelinating allergic encephalitis, duck embryo vaccine. This vaccine strain is grown in embryonated duck eggs. This vaccine has lower risk of allergic encephalitis but is considerably less immunogenic. A human diploid cell vaccine. This is currently the best vaccine available with the efficacy rate of nearly 70% and rarely any severe reaction. However, it's very expensive. Other cell culture vaccine, because of the expense of HDCV, other cell culture vaccines are being developed for developing countries. However, recent data suggests that much reduced dose of HDCV given intradermally may be just effective. Control of rabies. Urban canine rabies accounts for more than 90% of all human rabies. Control measure against canine rabies include stray dog control, vaccination of the dog, quarantine of the imported animals. Wildlife. This is much more difficult to control than canine rabies. However, there are ongoing trials in Europe where bait containing rabies vaccine is given to foxes. Success has been reported in Switzerland. Arenavirus, exposed single-stranded enveloped single-stranded RNA virus, variant 80 to 150 nanometer in diameter, genome consists of T2 base of ambisons single-stranded RNA, 7 to 8 nanometer spike protrude from the envelope. Host cell ribosomes are usually seen inside the outer membrane but play no part in the replication. Members of the arenavirus include Lassa fever, Gene viruses. Lassa fever virus particle budding from the surface of uninfected cells. Lassa fever found predominantly in West Africa, in particular Nigeria, Sierra Leone and Liberia. Multi-mate rats. Many may get infected through contact with infected urine and feces. Man-to-man transmission can occur through infected body fluid, and Lassa fever transmission can occur through infected body fluid, and Lassa fever can cause well-documented nosocomial outbreaks. Clinical manifestation: inoculation period of 3 to 5 days. Insidious onset of non-specific symptoms such as fever, malaise, Norwegian sore throat, typical patchy and ulceration. Pharyngeal lesion may be seen. Severe cases may develop from myocarditis and pneumonia, encephalopathy. Hemorrhagic manifestation: shock. The reported mortality rate of the hospital case of Lassa fever is 25%. It carries a higher mortality in pregnant women. Laboratory diagnosis: Lassa fever virus is group 4 pathogen. Laboratory diagnosis should only be carried out in the specialized center. Detection of virus antigen. The presence of viral antigen in sera can be detected by EIG. The presence of viral antigen precedes that of IgM. Serology: IgM is detected by EIG using the combination of antigen and the IgM antibody test. It was shown that virtually all Lassa fever infection can be diagnosed early. Virus isolation: virus may be cultured from blood, urine, throat, reverse transcriptase PCR, RT-PCR being used experimentally. management and prevention. Good supportive care is essential. Ribavirin had been shown to be effective against Lassa fever. Hyperimmune serum. The effect of hyperimmune serum is still uncertain. Post-exposure prophylaxis. There is no established safe prophylaxis. A various combination of hyperimmunoglobulin and oral ribavirin may be used. Shannon and Bacovovirus. Shannon and Bacovovirus are the causative agent of Argentine and Bolivian hemorrhagic fever, respectively. Calomys masculinus and C. calosus are the rodent vector. The clinical presentation are similar to Lassa fever. Unlike Lassa fever, no secondary human-to-human spread had been recorded. Hyperimmune serum and ribavirin has been shown to be effective. And the virus forms a separate genus in the Poniavirus family. Unlike under the Poniaviridae, its transmission doesn't involve an arthropod vector. Enveloped SS are a single-stranded RNA virus variant 98 nanometer in diameter with characteristic square grid-like structure. Genome consists of 3 RNA segments, LNM and S. History: hemorrhagic fever with renal syndrome, later renamed hantavirus disease, first came to the attention of the West during the Korean War when over 3,000 UN troops were afflicted. The transpired that the disease was not new and had been described by Chinese 1,000 years earlier. In 1974, the causative was isolated from Korean strep field mice and was called hantavirus. In 1995, a new disease entirely called hantavirus pulmonary syndrome was described in 4-corner vision in USA. Some subtypes of hantavirus associated with human disease, hantaborovia and related virus. This group is found in China, Eastern USSR, and some parts of Europe. It's responsible for the severe classical type of hantavirus disease. It's carried by strep field mice. Sole type associated with moderate hantavirus. It's carried by rats and have worldwide distribution. It's been identified in China, Japan, Western USA, and South America. Scandinavian countries, France, UK, and the USSR. It's carried by bankroll and cause mild hantavirus disease. Same number found in many parts of US, Canada, Mexico, carried by deer mouse and cause hantavirus pulmonary syndrome. Rodent carriers of hantavirus is strep mouse, bank vole, and the mouse, deer mouse, and the rattus. Clinical feature of hantavirus disease: the multisystem pathology of hantavirus disease is characterized by damage to the capillaries and the small vessels wall, resulting in vasodilation and congestion of the hemorrhage. With hemorrhage, classical hantavirus disease consists of 5 distinct phases. These phases may be blurred in moderate or mild cases: febrile phase, hypotensive phase, oliguric phase, and diuretic phase, and convalescent phase. The febrile phase, abrupt onset of the severe flu-like illness with erythematous rash after an incubation period of 2 to 3 days. Hypotensive phase begin at 5 of illness. Oliguric phase begin at day 9. The patient may develop acute renal failure and shock. Hemorrhage are usually confined to petechial. The majority of the diseases occur during the hypotensive and oliguric phases. Comparative clinical feature of recognized hantavirus disease: the virus type, the overall severity, multiphasic disease, renal abnormalities, hepatic abnormalities, hemorrhagic phenomenon, mortality and score. And this is the types. Hantavirus pulmonary syndrome: more than 25 to 150 cases of hantavirus pulmonary syndrome has been reported throughout the North and South America, with mortality rate of 50%. In common with classical hantavirus disease, hantavirus pulmonary syndrome has a similar febrile case. However, the damage to the capillaries occur predominantly in the lung rather than the kidney. Shock and cardiac complication may lead to death. The majority of hantavirus pulmonary syndrome cases are caused by same number virus. The other cases are associated with a variety of other hantavirus, New York or black renal virus diagnosis. Serological diagnosis, a variety of tests including HIF, HEI, ELISA has been developed for the diagnosis of HVB and HPS, direct detection of the antigen. This appears to be more sensitive than serological tests in the early diagnosis of the virus. The virus antigen can be demonstrated in the blood or urine. Reverse transcriptase PCR, RT-PCR, found to be a great use of diagnosing hantavirus pulmonary syndrome. Virus isolation of the virus from urine is successful early in the hantavirus disease. Isolation of the virus from the blood is less consistent. Immunohistochemistry useful in diagnosis, which is HBS. Treatment and prevention. Treatment of HVB and HBS depend mainly on supportive measures. Ribavirin reported to be useful. Vaccination and inactivated vaccine is being tried. Product control measure should be aimed at reducing contact with human and rodents.